In our next lecture, we shall solve some problems on theory of surface tension and angle of contact. These theories were taught in 2 short lectures earlier, and we shall now revisit those theories by solving simple elementary problems on the theories. As you are aware, in every chapter, we first solve some problems of basic level to understand the concepts even better, and then we go for a series of lectures on advanced level problems on the same topic to delve deeper. Same thing in this chapter as well. Let us go for the next problem that reads as follows. This is problem number 5. If surface tension is assumed to be a function of Kelvin temperature capital T alone, it may be shown that the surface energy is equal to gamma minus T into d gamma dt, where gamma is surface tension. If surface tension of water is approximately given by the formula gamma is equal to 650 minus T into 10 to the power minus 3 divided by 5 Newton per meter, what is surface energy of water at 300 Kelvin? This is the problem. So I have chosen the problem because it gives interesting insight into my theory class under the title Theory of Surface Tension, and particularly the subtopic relation between surface tension and surface energy. We had shown there that the total surface energy of free surface of a liquid may be composed of 2 components. One is the free surface energy and the other is the thermal energy. And surface tension is equal to the free surface energy per unit area of a liquid surface, and only in the particular case where there is no heat transfer between liquid surface and surroundings, only in that case surface tension can be shown to be equal to total surface energy per unit area. So that theory that we taught in this class, let us illustrate this with this example and learn a few more things about that. So, according to this question, surface energy is equal, by this they are meaning actually surface energy per unit area of liquid surface. Let me take the symbol to be E, and that is equal to gamma minus T into d gamma dt. That is my question number 1. Remember, here in the expression gamma is surface tension, T is Kelvin temperature, d gamma dt is the rate of change in surface tension as a function of temperature with temperature, and E is the total surface energy per unit free surface area of a liquid. And they are telling here as well that particularly for water, surface tension as a function of temperature is given by 650 minus capital T into 10 to the power minus 3, whole thing divided by 5 Newton per meter. And the question is, let me call this equation number 2 for reference, and the question is, at Kelvin temperature of 300 Kelvin, what is the surface energy of water? Once again, I remind you, by this symbol E, meaning surface energy per unit surface area of water. So how do we proceed? Looking at equation number 1, you can see to get this value of E, we require to find out the value of surface tension gamma, as well as the second term containing derivative of gamma with respect to temperature, d gamma dt, at this temperature of 300 Kelvin. Therefore, picking up equation number 2, we might proceed to find this derivative first, that is d gamma dt, that is d dt of gamma. Let me write this gamma from equation number 2, that is 650 minus T into 10 to the power minus 3 divided by 5 Newton per meter. In the next step, for convenience, let me break up this quantity and write separately as d dt of 650 into 10 to the power minus 3 divided by 5 Newton per meter minus capital T into 10 to the power minus 3 divided by 5 Newton per meter. When you differentiate the first term, a constant quantity, differentiation with respect to temperature becomes 0. And second term, d dt of T is only 1, therefore I am left with minus 10 to the power minus 3 divided by 5, and the unit is Newton per meter per Kelvin, isn't it? Here already the unit of Kelvin is there, and here Newton per meter, therefore the unit becomes Newton per meter per Kelvin. This is coming out to be minus 2 into 10 to the power minus 4 Newton per meter per Kelvin, a result that is independent of temperature. So you have found here, in case of water where surface tension varies as a function of temperature like this, the rate of change in surface tension as a function or with temperature, that is a constant quantity independent of temperature and negative, which means with rise in temperature, surface tension decreases. That we have already found in our data from the table of surface tension in the theory class. Now that was for d gamma dt. Let us now go to find out the value of this gamma surface tension of water at temperature of 300 Kelvin. So using question number 2 once again, we can write down that at temperature of 300 Kelvin, the surface tension of water is 650 minus, I put T is equal to 300 into 10 to the power minus 3 divided by 5 Newton per meter. This is coming out to be 650 minus 300, that is 350 by 5. That is 70 into 10 to the power minus 3 Newton per meter. Data is given to only one significant figure, therefore let me report it as 7 into 10 to the power minus 2 Newton per meter, or that is 0.07 Newton per meter. So you have got at temperature of 300 Kelvin, surface tension of water gamma is 0.07 Newton per meter, and we found the rate of change in surface tension with temperature is independent of temperature, that is minus 2 into 10 to the power minus 4 Newton per meter per Kelvin. So let us put these two values in equation number 1 and see the surface energy of water.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.